Hi friends, once again welcome back to our discussion. So we will be continuing our discussion on the chapter light. Okay, so in the last class we were discussing about what is reflection, how we can use mirrors to form the images, etc. And what are the important terms which we have to understand and which we have to study in case of concave mirrors, convex mirrors, etc. like principal axis, center of curvature, focal length, principal focus, then radius of curvature, the aperture, the pole, etc. Okay. So today also we have discussed the how the rays will be moving after reflection in case of concave mirrors. So I hope you are remembering all those things. So today we will be continuing our discussion on convex mirrors. So you know, convex mirror means it will be the mirrors which are bulged outwards. Okay. So in the case of a convex mirror, where will be the focus or where will be the center of curvature situated? Will it be on the left side or will it be on the right side? So I have told you how to find out the center of curvature. It will be the center of curvature is the center of the sphere of which the mirror was part of at the beginning. So the convex mirror will be like this, means it would have been a part of a sphere like this. So where will be the center of curvature? It will be on the right side of the convex mirror if we are keeping it like this. Okay. So it will be on the inner side of the reflecting surface. The reflecting surface is on the left side, means it in this figure it's on the left side. So the center of curvature will be on the inner side of the or the opposite side of the reflecting surface. Okay. So if we are marking it as the pole, this will be the principal axis. Okay. So then which will be the focus? This will be the center, the midpoint of the center of curvature, and the principal, and the pole will be the focus. Okay. So now here also, if we keep an object at infinity or distant object, a distant object in the sense the mirrors will be smaller. Okay, it will be so small that the center of curvature will be around what 10 centimeter something. Okay, the radius will be of 10 centimeters. So the perimeter or what the circle or the sphere with which the mirror was part of will be having a radius of around 10 centimeter, 7.5 centimeter, 5 centimeter. These are the mirrors which we will be using it usually. Usually we use these type of mirrors which will have smaller center of curvatures. Okay. So if the mirror is small, if I keep if I keep any object at a far away distance, that means even if it is at 1 meter distance, that will be according to this mirror. With respect to the smaller mirror, it will be a huge distance. That means it will be at infinity. So don't think that infinity means it will be thousands of kilometers away. No, it can be even 1 meter away with respect to the mirror. The mirror is so small, so with respect to the mirror, the infinity will be around 1 meter or even less than 1 meter or above 1 meter, greater than 1 meter, whatever it is. Okay, so don't think that infinity means it is in an interstellar space. No. It will be nearby to the mirror itself, but it will be comparing to the smaller mirror, the infinity, the distance of the infinity will be according to our conception. It won't be a huge distance, but according to the mirror, with respect to the mirror, that will be a huge distance or a longer distance. Clear? Okay. So if we keep any object at infinity, I have told you in the beginning, in the first class or in the last class, what I have told you, whichever object is at infinity, only parallel rays will be hitting the mirror. The other rays, it won't come. 360-degree the rays from the sunlight. From the sunlight, when the rays come and hit, arrow marks are important. Clear? Don't forget, arrow marks are important in any light rays. Okay. So when the sunlight is coming, it will reflect back those reflection it will be in 360 degree, but we will only see the parallel rays from infinity. But if we keep any object nearby, then it can come through anyway. So that's why in the concave mirror we have discussed the light ray coming through the focus, the light ray coming through the center of curvature, the light ray coming through the pole, and also the parallel ray. We have discussed all 4 types of rays. So here also we have to discuss the same thing. So whenever the rays are coming parallel to the principal axis, whenever the rays are coming parallel to the principal axis, it is parallel to the principal axis. Okay. So one more thing, the object always will be keeping on the left hand side of the mirror for our convenience, because in order we will be having a lot of calculations in this chapter. So for making the calculations easier or making it standard, the object will be always kept on the left hand side. Clear? Okay. The object will be on the left hand side. So the incident rays will always come from the left hand side in the case of concave mirror as well as convex mirror. So important point to be noted down again, one more important point, the object will be always kept on the left hand side. So the incident ray will be always coming from the left hand side of the mirror. Clear? So here the light rays is parallel coming, if any ray coming parallel to the principal axis, what will happen? At the point of incidence, what will be there? If we want to draw a normal, the normal will pass through where? The center of curvature, which we had discussed last class. Okay, the normal will pass through the center of curvature. So how will, and I have told you in the beginning, convex mirrors are diverging mirrors, concave mirrors are converging mirrors. So the reflecting rays will be coming together in the case of what? Concave mirrors. The reflecting rays will be shattered away or moving away from the mirror in the case of convex mirror. So what will happen? The light ray is making, the incident ray is making some angle, angle of incidence with the normal. So the light rays should move in such a way that it makes an angle, the same angle with respect to the normal, so that the laws of reflection is satisfied. Okay, so angle of incidence will be equal to angle of reflection. So what we will understand is that it will reflect. So how we will say it? It will reflect and it will diverge away. But we will feel that this reflecting surface, this reflecting ray is coming from the focus. We will feel that this reflecting surface, the reflecting ray is coming from the focus. This reflecting ray, we'll feel that it is coming from this point, this focus. Okay, in the case of concave mirror, we have seen that the light ray is originally passing through the focus, but here the light ray is, we'll be imagining that the light ray is coming from the focus, from the point focus. So how we are imagining, like when we are standing in front of a plane mirror at a house, we are seeing ourselves on the mirror, but we are imagining that someone is standing there. It's not a real image, it's not at all real, it is virtual. I have told you in the beginning, it's virtual, not real. Okay, so likewise, this is also not real. We will feel that it is coming from the focus. Okay, we will feel that it is coming from the focus. So if any ray is coming parallel to the principal axis in case of convex mirror, the light ray will be moving away. The reflected ray will be moving in such a way that it comes from the focus. That's clear? Okay. So one more ray, the next type. Convex mirror, center of curvature, principal focus, pole. Okay. So here the ray is coming in such a way that it is passing through the focus. The ray is coming in such a way that it is passing through the focus. So what will happen? In the case before, what was happening? the ray coming through the focus, it will go parallel to the principal axis in order to follow laws of reflection. So here also laws of reflection is there. So what will happen? The ray will be the center of curvature, the normal passing through center of curvature will be like this. So this will be the angle of incidence. So how will it move? In such a way that so this is the angle of incidence. So it will move in such a way that it is parallel to the principal axis. The ray will reflect and it will move in such a way that it is going parallel to the principal axis. It is moving parallel. The light ray is parallel to the principal axis. Okay. So that is the second case. The third case is center of curvature, focus, principal. While I am drawing, you also take your pencil, scale and notebook and draw it with me, so that if you draw more, the better you understand. If you understand it, the better you can do the problems. So in this chapter, mainly we will have to discuss a lot of problems using these image formations, using these ray diagrams. We are moving into that. So we are having some formulas like mirror formula, lens formula, etc., magnification values, etc. So we will be understanding the relationship between the object and the image. Okay, we are going to study how the image is formed, where the image is formed in this chapter. So while we are studying it, we will have some formulas, and with using these formulas, we will be studying the relationship between the object, the image, at what distance the object is kept, at what distance the image is formed, what is the difference between the size of the object and the image size, or the height of the object and height of the image. If the tree which is at infinity means it can be at 2 meter, 3 meter distance or 4 meter distance. Okay. So any big tree, it's a huge tree, but what we will understand is the astonishing fact is that the image formed will be highly diminished. A small point size image of the tree can be formed using concave mirrors. So how is it possible? Why is it possible? What is the relationship between them? We are going to study that. Okay. So for that we need these types of rays. How the rays will be moving after incidence, after the incident ray comes and hit on the surface, how it reflects. Those ways we need to understand. So for that we are discussing these points. Okay. So the third ray, it is coming through the center of curvature. Before it was coming through the focus. Now it feels that it is coming to the center of curvature. What will happen? There is no doubt normal incidence. You refer what is normal incidence once again. So normal incidence happens, it will move through the same path. It will retrace its path. Okay. So I hope that's clear to you. There is no doubt in that. That's clear. Okay. Now the last one, it is a ray coming and hitting at the pole. The ray coming and hitting at the pole. So what will happen? It will make equal angle. So this is at the pole means this is the normal. So it will make equal angle with the principal. So this is diverging one. This is coming like this, it diverges away. Okay. So it is not done. Converging means it should it will be coming together, but it is moving away. So it is diverging. Okay. So these are the 4 types of rays in case of convex mirrors. I hope it's clear. So be thorough with the types of rays in case of concave mirror and convex mirror. And now we are moving on to the important portion of this chapter in case of reflection. The important portion in case of reflection, that is image formation. That is image formation in case of mirrors. The reflection is dealt with mirrors, and the new term refraction, which we will be studying in the next classes, the refraction is dealt with lenses. I will explain what is lens, and you might have seen lenses, the magnifying lens, the reading lens, etc. in the binoculars. Okay. So the difference between lens and mirrors, what is reflection, what is refraction. Reflection you understood now, refraction we will understand. Now in case of mirrors, due to reflection, image is formed. I have told you in the last class, when two reflected rays intersect, at that point image is formed. At least two reflected rays are required for image formation. So we can see images, and why we are seeing images, that's only because of intersection or meeting of reflected rays happens. Clear? Okay, so now we are moving on. The first case we will be discussing concave mirrors. Concave mirrors. First case we will be discussing concave mirrors. Clear? Okay, in case of concave mirrors we are having 6 image formations. What we are doing is, we will be having any object, let it be a candle. Okay, let it be a candle. Let it be a candle. So what we will do is, we will keep the candle at different positions with respect to the mirror, and we will be studying the characteristics of the image formed. Okay, we will be studying the characteristics of the image formed. Where is the image formed? First question what we want to find out, where is the image formed? What is the type of image? What type of image is formed? What is the size of image? So these are the things which we want to discuss in this image formation by a concave mirror. So what we will do is, we will keep the object at different positions, Okay, so first we will keep it at infinity, a longer distance with respect to the mirror. Then what we will do is, we will bring it closer to the mirror at C or beyond C, near to C we will keep it. At infinity we will keep it first, then we will bring closer and we will keep it at the center, near to the center, not at the center, near to the center. Then again we will push it near towards the mirror again, and we will keep it at the center of curvature, at the point center of curvature. Okay, then we will again move it inside, so that we will keep it between the focus and the center of curvature. Then we will keep it at focus. Then what we will do, we will keep it between the pole and the focus. And at all these positions of the object, we will be trying to discuss, or we will be trying to understand the different types of, what are the peculiarities or characteristics of the image formed. Clear? Okay, so the first case we will be keeping at infinity. The object is kept at infinity. The object is kept at infinity. Okay, at infinity. So what we will do? Concave mirror. So what I am drawing this one, in order to understand that this is the rough surface where the reflection won't occur. Inside position will be the reflecting surface. Okay, understand it. So draw it with me. This will be the center pole. Then we will have a line, center of curvature, focus. Clear? Okay, focus. So the object is at infinity, so it will be at a far away distance with the candle or the object, any object, it will be at the far away distance from the mirror, so at infinity. Okay. Now what will happen from here? What rays will only come if it is at infinity? Only parallel rays will come, isn't it? So we will take only 2 types, any 2 types we can take, any 2 types. So here we will be taking, but here only parallel rays are coming, so we will have 2 parallel rays to the principal axis. The rays are coming, the rays are incident parallel to the principal axis from the okay, from the candle, the rays we will take, there are a lot of rays coming, and also it is going away also, but since it is at infinity, we will only take the parallel rays, and also in that parallel rays we will only consider 2 rays, because we need to make it intersect. Only 2 reflected rays should intersect for our image formation. Okay, so what will happen? This ray will pass through the focus after reflection. This ray will also pass through the focus after reflection. Clear? So where is the image formed? This is the meeting point of the 2 reflected rays. So this ray will be going like this, but here also intersection happens, but will the image form here? No, because one ray is incident ray, the other ray is reflected ray. So we need at least two reflected rays. Okay, so what will happen? So what we will understand is that the two reflected rays are meeting at image formed at F. Image is formed at F. Okay.